Let us look at another example of forecasting using the linear regression analysis method. The sales of a company in millions of dollars are as given below. So this company had a sales of $82 million in 2006, $80 million in 2007, $90 million in 2008, and so on. We have been given this data till 2013. Now, using the principle of least squares, fit a straight line trend equation to the above data. Also, determine the sum of squares of deviation and forecast the sales for the years 2014 and 2015. So basically we have to use the principle of least squares and forecast for the years 2014 and 2015. And also we need to determine the sum of the squares of deviations. So let us solve this example. Now in this example we have sales varying per time period. So here time is the independent variable while sales is the dependent variable. Basically, the dependent variable is the one that we need to forecast, and sales varies per time period, so sales is the dependent variable. Now, in linear regression, the relationship between the variables is assumed to be a straight line. So the equation for simple linear regression can be written as y is equal to a plus bx, where y is the dependent variable we are solving for, a is the y-intercept. What this means is that a is the point on the y-axis where this line will intersect the y-axis. B is the slope of the line, and x is the independent variable. In this case, this is time. So basically, if we can find the values of a and b, then we can easily find the values of y by entering the value of x, and x is nothing but time. So how can we find out a and b? So for a, let's have a on one side of the equation and let's bring bx on the other side of the equation. So we get a is equal to y minus bx. Now since we have multiple data points, so we have multiple values of y as well as multiple values of x. So in order to find a, we'll take the mean of all these values of y and x. And b is equal to sigma xy minus n x bar y bar divided by, now for the denominator what we'll do is we'll replace all y's with x. So sigma x square minus n x bar square. So here y bar is the arithmetic mean of all y's. X bar is the arithmetic mean of all x's. X is the x-axis values of each data point. Y is the y-axis values of each data point. N is the number of data points. So basically we have the values of x and y. Now we need to find the multiplication of x, y for all these values and then add them up. We need to find the mean of x, mean of y. We need to find x square and x bar square. And then we'll be able to find b. And once we find b, then we can easily find a. So let's find out these values. So here I have noted down the values of time and sales given to us. Please note that the time was given to us in years. For example, 82 was the sales for 2006, 80 was for 2007, and so on. And I have converted them into 0, 1, 2, 3, 4, 5, 6, 7 for ease of calculations. Now time is x and sales is y. Now first we'll try to calculate the value of b. So the first we need to find is the value of xy. So we have x, we have y. So let us find the value of xy. So basically what we need to do is multiply these two values. So 0 multiplied by 82 is 0. 80 multiplied by 1 is 80. 90 multiplied by 2 is 180. 92 multiplied by 3 is 276. 83 multiplied by 4, so 4 3s are 12, 1 carryover. 8 4s are 32 plus 1 33. 94 multiplied by 5, so 5 4s are 20, 0 2 carryover. 9 5s are 45, 46 and 47. 9 6 are 54, so 5 carryover. 9 6 are 54 plus 5 59. 92 multiplied by 7, 7 2s are 14, 1 carryover. 7 9s are 63 plus 1 64. Now next we need to add them up. So let me pull my calculator here. So 0 plus 80 plus 180 plus 276 plus 332 plus 470 plus 594 plus 644. 2576. So the total here is 2576. So we have found this part, that is sigma xy. Now we have to find x bar y bar. So x bar is equal to sigma x divided by n, and y bar is equal to sigma y divided by n. So let's find out sigma x and sigma y, which is nothing but the total of these two. So let me pull my calculator. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, 28. So this is 28. Next let's find sigma y. So 82 plus 80 plus 90 plus 92 plus 83 plus 94 plus 99 plus 92. So this is 712. 712. So we now have sigma x and sigma y. So let us calculate x bar and y bar. So sigma x is 28 divided by n, which is 8. N is 8 including 0 because there are total of 8 data points. So this is equal to 3.5. Sigma y is 712 divided by 8. So this is equal to 89. So in this formula we now have the values of x bar and y bar. Next we have to find out sigma x square. So let's find out the values of x square for each of the data points. So x square. So 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49. And then we have to take the sum of all of these. So let me pull the calculator. So 0 plus 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. 140. So this value here is 140. So now we have all the values needed to find the value of b. So let us calculate the value of b. B is equal to sigma xy, which is 2576, minus n, which is 8, multiplied by x bar, which is 3.5, multiplied by y bar, which is 89, divided by sigma x square, which is 140, minus n, which is 8, multiplied by x bar square, which is 3.5 square. So let me pull the calculator. So 2576 minus 8 multiplied by 3.5 multiplied by 89. This is 84. So numerator is 84 and this divided by 140 minus 8 multiplied by 3.5 square. This is 42. And 84 divided by 42 is 2. So the value of b is 2. Now let's put this value in the equation for a. So a is equal to y bar, which is 89, minus b, which is 2, multiplied by x bar, which is 3.5. So this is equal to 89 minus 3.5 multiplied by 2 is 7. So this is 82. So now if we put the values of a and b in the equation of the regression line, which is y is equal to a plus bx. So we get y is equal to 82 plus b is 2 multiplied by x. So this is the equation for the regression line. So the first part of the example is done, which was to find the trend equation for the data given to us. Now the second part is to determine the sum of squares of deviations. So let us find that. Now part B is determine the sum of squares of deviations. Determine the sum of squares of deviation. Now what is a deviation? So let us understand this first. So let's say we draw a graph with time on the x-axis and sales on the y-axis. So time is here, this is let's say 1, 2, 3, 4, 5, 6, 7. And then we plot these points. So let's say this come out as this one here, this here, this here, this here, and so on. And then we are fitting a straight line into this point. So let's say that this is the straight line. Did not come out very straight because I'm not drawing on the scale, but consider this as a straight line. Now each of these points which have been given to us can be considered as y. So let's say this is y1, y2, y3, y4, y5, y6. Now corresponding to each of these data points, let's say for y6, so at that point corresponding to that x value, we can put a point on the straight line. So let's say this is the point corresponding to y6. Let us call this as y6 dash. Similarly here y5 dash, y4 dash, and so on. Now this distance here is the deviation. So in order to find the deviation, we already have the y data points. So let's say we have y6. We need to find the corresponding point for the same value of x on the regression line. And that point will then become y dash 6. So basically what we have to do is we have to put all these values of x in this equation of straight line, and then we will be able to get the value of y dash. So we now have to calculate y dash. So we'll put 0 as the value of x here. So y is equal to 82 plus 2 multiplied by 0, which is equal to 82. So this is 82. Now for 1, y is equal to 82 plus 2 multiplied by 1. So this is 82 plus 2, which is 84. And so on. So let me note down the values. Basically all these values will be 2 more than the previous value because we are multiplying 2 with the time values which are in sequence. So this will be 86, 88, 90, 92, 94, and 96. So we have found the values of y dash, but we have to find the deviation, which is y minus y dash. So basically 82 minus 82, which is 0, 80 minus 84, which is minus 4, 90 minus 86, which is 4, 92 minus 88, which is 4, 83 minus 90, which is minus 7, 94 minus 92, which is 2, 99 minus 94, which is 5, and 92 minus 96, which is minus 4. So here we have found the deviation, but we need to find the sum of squares of deviations. So we need to find the square of these values. So y minus y dash square. So this is 0, 16, 16, 16, 49, 4, 25, 16. Now we have found the squares of the deviation. We need to find the sum of squares of deviation. So we will add all these up. So let me pull the calculator here. So 0 plus 16 plus 16 plus 16 plus 49 plus 4 plus 25 plus 16. So this is 142. So this is the sum of squares of deviation. Now remember, we have used the least squares method to find this trend equation, and as per the least squares method, the regression line should minimize the sum of squares of the vertical distances or the deviation between each data point, that is y's, and its corresponding data points on the regression line, which is y dashes. So basically this value is minimized using the least squares method. If you draw any other line, then this value will be more than 142. Now let's move to the third part of this example, which is to forecast the sales for the years 2014 and 2015. So part C is forecast the sales for the years 2014 and 2015. So here we have found the regression line using the data given from 2006 to 2013. So let's assume that this is the line, this is the point where 2013 is here. Now if we extend this line further, this is a straight line, so we can extend it further, and then we take the data point of 2014 and we bring this here and then extend it on the y-axis. So then this point will be the sales for 2014. Similarly, if we do for 2015, we'll find the sales for 2015. Now we have this equation here. So basically what we are doing is we are putting the value of x and we are getting y. So 2013 was represented as 7 here. So we'll consider 2014 as 8 and 2015 as 9. So let's plug in these values of x in this equation, which is the equation of the regression line. So y for 2014 is equal to 82 plus 2 into x, which is 8. So this is equal to 82 plus 16, which is equal to 98. So again, this value is in millions of dollars, so $98 million is the forecast for 2014. Similarly, y for 2015 is equal to 82 plus 2 multiplied by 9. So 82 plus 9 2s are 18. So this is equal to $100 million. So these are the sales numbers for 2014 and 2015 using the linear regression method.